we can see the linear integrated circuits, and these are the syllabus. That is it covers in the first unit, it covers the basics of operation amplifier. Second unit, we can just going to study the applications of operation amplifiers, and the third unit is consists of analog, multiplier and PLL, and also its applications. The fourth unit, we are just going to study about the types of A to D converters and D to A converters, and also in the fifth unit we are just going to study about the waveform generators and some of the special function ICs. And these are the textbooks and reference book. First we can see what is meant by operation amplifier. Here the operation amplifier means, that is the operation amplifier, it is otherwise said to be op amp. It is a device that is used to amplify either AC or DC signal with the help of some external power supply. And also the operation amplifier is generally composed of transistor, resistors and capacitors. Therefore op amp means it is used to amplify the signal using the external power supply. And also it is available in the form of three popular packages, that is metal can package, dual inline package, flat package or flat pack. And also the flat packages may also contain single, two or quad. 2 means it is said to be dual or quad op amps. And also they are available in the form, the packages may also have 8 terminal 10 terminal, that is 8 terminal, it is available in the form of dip. 10 terminal, it is available in the form of flat packages or dip packages. And mainly the popular IC we are normally using is New A 741, and it is a single op amp, and also it is available in 8 pin can, 8 pin tip, 10 pin flat pack or 14 pin tip. And also here in the form, in the case of Mu A 741, it is a dual 741 and also comes in either 10 pin can or 14 pin tip. Now we can see the op amp terminals. This figure shows the schematic diagram of Mu A 741, and this is the exam IC Mu A 741. Here the op amp have 5 basic terminal, that is it consists of 2 input terminals, one output terminals and 2 power supply. Here the input terminals are negative in the inverting terminal, that is inverting terminal, and second pin is inverting terminal, and the third pin is non-inverting terminal. And here the 1 and 5th pin are offset null, and here in this 8th pin we are not giving any connection, or it is not we are not using that pin. And this 7 is for positive power supply, and 4th pin is for negative power supply, and here from the 6th pin we are just taking the output. Here if you are going to see about the basic information of this operation amplifiers, here the operation amplifier, it is a direct couple high gain amplifier which consists of one or more differential amplifier followed by the level translator and an output stage. And also we all know that it can also be amplified either AC as well as DC input signals. And also some of the applications of this operation amplifier are, it can be used to perform mathematical functions such as addition, subtraction, multiplication, integration and differentiation. And this is the symbol of operation amplifier. Here to the second pin we are just giving the inverting input. For the first third pin we are just giving the non-inverting input, and here for the 7th and 4th it is for power supply, we all know that. And from the 6th pin we are just taking the output. And here this is the already we have seen, there is 3 terminals which is consists of 2 high input impedance, that high impedance input, that is one of the input is called an inverting input marked as negative or minus sign, and the other one is non-inverting input, that is marked as positive or plus sign. Okay. Now what is ideal operation amplifier? Here the operation amplifier is said to be ideal if it must have these following characteristics, that is it must have infinite input impedance, 0 output impedance, and also 0 input offset voltage, that is V0 equal to 0 when V1 equal to V2 equal to 0. Okay, when both the inputs are 0, the output must also be 0. And next one is infinite open loop gain, and the last one is infinite bandwidth. These are some of the characteristics of operation amplifier. Okay, now we can see that there are 2 basic types of operation amplifier, that is inverting operation amplifier and non-inverting operation amplifier. First we can see the inverting operation amplifier. Here In the case of inverting operation amplifier, here the feedback to the inverting input terminal, that is the feedback, the output voltage V0 is fed back to the input inverting terminal through this resistors R2. Okay, through, and also therefore this resistor R2, or in some other books they are noted as RF. It is called the feedback resistor. And here the input signal Vi is applied to the inverting input terminal through R1, and non-inverting input terminal of the op-amp is also grounded. Okay, and also for simplicity we are just assuming that this is an ideal operation amplifier. So in the case of ideal operation amplifier, we are just assuming that there is Vd equal to 0, that is the difference between the two input voltage is equal to 0. Therefore at node A, we are just grounding this node A, and therefore the current flowing through that particular node A is I1. We are just taking that current as I1, and it is called as, and it is can be written as Vi by R1. Also the current, also the output voltage V0 can also be written as minus I1 into RF. Why we are using this negative sign means the voltage is again fed back, that is its output is again fed back to the input, therefore we are just using this negative sign. And here if we are substituting the value of V0 in the I1 in this equation, and finally by calculation we are just getting the closed loop gain as V0 by Vi equal to minus RF by R1. Okay, V0 by Vi equal to minus RF by R1. This is the closed loop gain of this inverting amplifier. And next one is non-inverting amplifier. Here in this non-inverting amplifier, here in the case of non-inverting amplifier, what we are doing means, here we are just giving the input to the non-inverting terminal. The input is given to the non-inverting terminal, and and here in this case there is no the output voltage is not fed back into this particular input of this particular op-amp. Okay, as the differential voltage Vd at the input terminal of the op-amp is 0, the voltage at node A is Vi, same as that of the input voltage applied to this non-inverting input terminal. Okay, and also here we are just applying the nodal equation, and by using this nodal equation and after solving we are just getting the voltage gain as AB equal to 1 plus R2 by R1. This is the closed loop gain for this non-inverting operation amplifier. Therefore for the inverting operation amplifier we are just getting as minus RF by R1, and in the case of non-inverting operation amplifier it is given as 1 plus R2 by R1. Okay, thank you.